All right, I'm back with Space Torture. So yesterday I came and played, and I was a little tired. Just wanted to play something chill, and we started to get into a bit of the tricky areas, which is, it's good and bad. It was bad yesterday, but in general, it's good. That's what we want to start getting into, the fun stuff, the confusing stuff. We want to learn something. So today I jumped back into the game, and I poked around with some of those earlier levels. And what I'm going to do right now is I didn't advance, even though I did get the the answer for this one. I kind of did it, and then just before it completed, I reset the level so it wouldn't count. So I know what I'm doing a little bit more now. But I'm going to jump through these with you and kind of understand what I was doing wrong. Because I think if we don't understand what we're doing at its core, it's kind of pointless at all, right? So this one is the parabolic movement is along two axes, right? So it says we need a constant acceleration along an axis and a constant velocity along the other axis, right? So we know what to do here. We know in 5 seconds we've got to go 5, 10, 15, 20, 25, right? We've got to break that up to 5 seconds a pop across here. But then on the y-axis, we need to also displace 25, because this is y25. So what's the displacement here? Well, we have 5 seconds. We need to be 25, so that's 2. So we know to just put a 2. And that's kind of a simple one, right? So we figured that one out pretty quickly. Let's get out of here. We'll skip the next two, and then we started to get a little bit trickier. Because this one, actually what it asked us to do is do a bit of a curve and then run straight down here. So what we actually ended up doing was we had to position ourselves minus 30 plus 20. Then we are going to head down here, which is 60, right? So 20 minus 40. So we need to move 60 meters over 6 seconds, which is, minus 10, right? Because we're going negatively. So that's correct. Now we're moving down here, and we need to displace off to the side. So displacing off to the side here, we need to actually displace ourselves about 12. We only need to go about 12 from minus 30 to minus 18. So to go 12 in 2 seconds, because you can also see that this is going to be 1 second, 2 seconds on the third battery. In 12 seconds for 2, that's 6. So we go at our x is going to be 6 for 2 seconds. And then if we play that, we can see that we kind of curve and then we shoot down and we continue there. So we started to understand that one as well. So we can skip this next one. Then, this is where we started to we tricked a little bit. Introduction to an acceleration with a positive initial velocity. This is where we got now that second, more confusing graph. The second, it says to help you accelerate with a positive initial velocity of plus 10, use the table in our instruction manual. And now we have the more complex one. And whether it's positive or it's negative, it's pretty much... Oh, that's a little bit weird, isn't it? How that's... should pretty much be the same image with different numbers, but I guess not. But yeah, that's... You can see how it's just a chart for if it's positive or negative. It doesn't, make too much of a difference. Minus 15 and minus 5. And on the other one, it's 5 to 15, right? It's flipped and it's, negated, basically. So those two graphs are pretty much the same, but you can see we're using this new graph now. So what we're doing is we're actually moving along here at plus 10, when this graph is, you have to be plus 10. And then we need to reach 56. So to get to 56 in 4 seconds is here, 2 meters a second. And that's still along the x-axis. So this is the weird thing where we already have the initial velocity along the x, and I'm giving us an acceleration on top of that of on the x. We're ignoring the y for now because we're only going straight forward. And with that displacement, instead of going where we would get to in 4 seconds, which is 40, now we're going to get to 56. Then we moved on. Then we got to this one, which was going backwards. It's kind of pushing us and displacing us backwards. We'll jump to the one after that. I just kind of walking you through the process of what I was doing today and understanding how all this works. And Actually, I realized the reason this is like this is because my videos keep getting demonetized for having the music on. I don't really care too much though. We're not here to make a lot of money or anything on YouTube, so we're gonna just leave that music, let it ride. It's nice and relaxing anyway. So this one, what we want is an initial velocity, positive y. We still want that 10, right? But now we need to go down to minus 24. So we have 4 seconds. So where's minus 24? Here it is. Minus 8 on the y. So even though we're going up at a positive 10, this is going to push us back down over 4 seconds to that negative. So it's telling us this displacement. Now, this is where we got lost. This one here. Introduction to parabolic movements with acceleration and a positive initial velocity along an axis. So this is where we lost it. Look at this. Oh, it didn't tell me this time. It actually didn't come up with like a little hint. But what we actually need to realize is that we need to make, this is already 10, and we need to also have a velocity of 10 in both directions so that we're actually heading up here at an angle, and then we curve off from there. So we're going to start down here at minus 25 minus 15. Oh, wait, that's not minus 25, 15. Is that better? Oh, it does say minus 25. Minus 25 minus 15. And instead of just having this velocity, which is, you know, positive along this way and we're curving off, we have a velocity of both. So we're actually going up here at an angle and then curving off. And then we need to... Where are we heading here? So, we have the displacement is going to be from where we start. So minus 15 to minus 6. That's a displacement of 9. Then here is 1 from minus 15, which is 16. And then from here is 6 from 15, which is 21. So we need 9, 16, 21. And you can see here, 9, 16, 21. We're actually finding all of these displacements in a row, which is what we're looking for. So we know it's minus 2. And we're heading minus 2 on the x-axis. Oops. And let's try this. Oh! What did I do? Minus 2 on the y. Here we go. What have I... Oh, I didn't do this. That's why. And now it is minus 2 here. Oh, I was confusing myself. I removed the extra velocity that I said that we needed on the x-axis. So we need velocity on both axes. What have I done? I just changed it back. Loser. I've broken my brain. What is going on? Here we go. This is 9. You can see this is 9, 16, 21, 24, 25 at 5 seconds. So what we're doing is we actually need to go at 5 velocity here because we need to double that. You see, so this actually is 5 a second because this is need to be doubled to 10 seconds basically to get to that same range. That's what I'm confusing myself already. Trying to explain what I did to learn what I'm doing, and I'm already confusing myself. But you can see what we've done. Did we speak about Dennis? Oh yeah, the steam engine. So now we have another parabola, and this is where we got stuck. So what we need to do is we should start up here on 30-20, 20-30. I'm going crazy. 20-30. So as cars up here, we're going negative y. We're coming down here, but we're also going negative x because we want to come down at this angle. And then you can see this displacement is from 20 to 27. So that's 7, then to 8. That's 8, then to 3. So 7, 8, 3. But then it's where 12 from 20. So negative 8. So 7, 8, 3, negative 8. And you can see 7, 8, 3, negative 8. So it needs to be minus 6 here. So we got minus 6 on the x-axis. Where am I going here? What am I doing? What am I doing here? No, no. We're trying to go positive this way. We're trying to... You see how we're trying to move this way? And then it's pulling us back because we need the negative. I'm trying to go positive X and it's pulling us back to negative. Not trying to go negative X and then curve away from it. So we actually need velocity in both axes, which is what I wasn't understanding. I'm going to get... And we're going to do the next one as well and then jump to that third one. See where we are. Okay, so... We can start from, once again, the bottom corner, which is, we see, minus 30, 30, 30, minus 30. And our displacement, so if we go positive y and negative x, so we're going to go up here and here, so we're going at this angle, right? Then we need our displacement to be from 30 to just straight 20. So that's 10. And then, what's that, 18? 10, 18. Okay, let's see. We got 10. Have we got 10 and 18? Am I doing this the opposite way around? Where I should? I think I'm doing the opposite way around. Oh, wait, we only have 3 seconds on this one. We only have... Whoa, 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 whoa. We only have 3 seconds. So we got 1, 2, 3 seconds. We got 1, 2, 3. So in 1 second, we need to be negative 17 from... It needs to be 20 from 30, which is a difference of negative 10, right? 10. In 1 second, 10, and then 20, then 30. That's not going to fit. What have I done wrong here? I think... Okay, so we want our initial velocity of... positive y, so we're going up here, and we want to curve off here on the x. Okay. And what is the displacement here from here? Maybe what we want to do is the displacement on the y. And head up here. So we start here again, but we're actually going from 30 to negative 30, and we're going up here. And the displacement's on the y, sorry, not the x, because we're going up from this way. We're not driving up here. Okay. So the acceleration is actually from 30 to 17, which is, obviously we've got a difference of 13. And then from here, which is 2, so we've got 32. 13, 32, here we go. And then the other one, 57. So that's 6 on the y. Here we go. Let's see. Yeah, sorry, I'm doing it on the x-axis. Fool. So we've done it. We've kind of cracked it. We've kind of starting to understand it a little better. Let's jump into the next one, then I'll read some of these scientist ones, because I think we're going to get stumped again. This is another jump. Now we're dead. Now we are dead. Are we're gonna displace? Oh my god, this is so sick. Now we're gonna displace. And now it wants us to go initial velocity of negative 10 along an axis. Okay. This is the same though, as I said. This is going to be interesting. So, where do we want to start? Let's start bottom left. Minus 30. Minus 25. We want to be going initial velocity of positive y and positive x, so up here. And then we are going to displace, so 25, minus 25 to minus 15 is 10, and then to 5 is 20. So we've got 10, 20, wait a second. Are we, but then we got 25 to 15, 10, and then to 5, but then that's another 10. We got 10, 10, 10. What am I doing? The displacement, I'm doing it all wrong. 10, 10, 10, 10. 10, 20, 0, that would be. Okay, we're doing that wrong. That needs to be on the x-axis then. So on the x-axis, what's his displacement? That's minus 30. Minus 22, that's 8. And then 18. Okay, so that's 12. 8, 12, 8, 12. I see positive 4. Positive 4 on the x. And then we should be going 1, 2, 3, 4, 5. After 5 seconds, we need to... So we're going curving around here. Boom. And then up here. So we want to teleport down here. And continue moving up on the Y. So we have 10 seconds. We need to move 1, 2, 3, 4, 5. Teleport 1, 2, 3, 4, 5. Okay, yeah. So we do need to move 10 and 10. That's correct. And then at 5 seconds we displace. So this is at 4. That should be at 5. And then it should be what, negative on the other side? Is that how we're doing it? Let's see. Negative on the other side. Let's see. And we're going to teleport down here to 30. Minus 25. Let's just see what happens. I'm curious now. Have we... I'm going off the wrong way. That's only... Oh. But what is that on the... We're going positively on the X. Why am I doing that? I've lost it. Come here. We need to be going okay. Parabolic. We're going down. This is where we get demonetized, when I'm thinking and the music's playing on its own in the background and I'm not talking over the top of it. We would start down here. We are going to be moving over here. Right? Up here. And we need to displace negatively into the Y. And we need to displace... sorry, we need to displace negatively into the X, right? So... we are displacing negatively into the X. But that's not what happened. It sent us off that way. Okay. Don't we need to do this? I don't know. Let's see. What is that? I did it the wrong way around. I just went off into the positive instead of off into the negative. We knew what we were doing. We knew what we were doing. And then we're trying to decelerate on the other side. Okay. God, I'm confusing myself with silly little things now. There's a lot to cover. There's a lot to cover. I think I'm going to do another one because it goes up to 7 difficulty. And then I'll read the 4 people. And then we'll do that last level in this area. But damn, it is getting very complex now. The thing is, I don't want to do this. I'm not doing this for nothing. I want to understand it. If I don't understand it, I'd rather not play the game. I'd rather not play the game. I want to come away understanding more than I came in with. And it's doing a good job of that. I do wish there was some better explanation for certain things. It's kind of more like it's not really teaching you and then kind of getting you puzzles, so like, can you solve this kind of thing? Sometimes is how it feels. Can you solve this? The hints maybe are what are going to help us out, but we're trying to avoid hints as well. But let's do this. So we're going to start here and we're going to go here and teleport here. Okay. So let's start. Minus 25, positive 5. Car velocity, we're going positive and positive. 10 and 10, so once again up here. And we are trying to displace. So we're going up here and we're trying to displace along the y-axis negatively. So first from 5 to 13, we've got We got 8 there, and then 17. That's 12, 8, 12, 12. Do we have something that looks like 8, 12, 12? Here we go. So 4. Let's do 4 on the Y. Oh, we're trying to go negatively though. -4 on the Y, and that's going to be for 1 second, 2 second, 3 second, 4 second, 5 seconds. And then we want to teleport down to -30. No, -5. -30. And from there, we're going to be 5 to 8 seconds. I'm just gonna go and see what happens first, because I want to be solving that first part, right? And then we need to see how the car behaves. I've done it was -10. Damn it, I'm an idiot. Okay. -10. Or do we want to be going this way then? Because we don't want to. No. So, -10. Do we want to teleport here? Because now we're going -Y displacement. Let's teleport here instead. So we're teleporting to +10, 0. And why don't we just, I'm just going to see what happens, +4, just to opposite directional kind of deceleration. Oh, we have to do it after 6 seconds. We want to do that after 6 seconds. And what happened at the end there? Where did we go? We went off in the complete opposite direction. So I'm going to do nothing here. And see what happens. Didn't we change it to 6 seconds? Oh. 5 seconds. After 5 seconds. 1, 2, 3, 4, 5. This. Oh, we did this to 6. And then we did this to... Okay, right. So they both need to be 5. 1, 2, 3, 4, 5. So we've got this first area complete. But then that's negatively going from there. So that's not working. If we have it as -10, -30... Because this is going still +X and -Y though. So it should be -35. God, I'm clicking the wrong thing. I'm saying what I'm doing. And then I'm not doing what I'm saying. So we go from here, but then we should be going... Wait a second. I don't know what's going on there, but that is actually 11. So we actually need to start somewhere that's more serious, like this. Maybe what we actually need... Well... If we start from here and do the parabola in reverse, and then we're going -X and -Y, and then this goes -X and -Y, let's do that instead. Let's do it from the other side. I think that's what I should have been doing. So we start at 25.5. 25.5. Boom, boom. And we have a negative parabola. And we're going to go +Y, are we? We're going... No. We're still going -Y. This way. And then after 5 seconds, we're going to teleport ourselves to 10, 0. Which is where this is. Yeah, 10, 0. And let's see what happens there. And this is after 5 seconds do this. Because this is 1, 2, 3... 1, 2, 3, 4, 5. And then after 5 seconds, do nothing. We'll see what's going on. What the hell have I done? What the heck have I done? We're going -X, negative... Oh, we need to go +Y there. To go up at this angle. Oh dear, I do kill myself. I do crack myself up. Right, so we still need... We need it to continue. So can't we just do this to 7 seconds? I mean, doesn't it... 5 seconds and then we go from 5 to 8 and just do the same thing? -4? Or is it actually different? Because this curve matches this curve here coming from here, right? Yeah, so it's the same thing. What I did is I started from the top left because that's just kind of what I've been doing. But actually the curve is from the other side, so it kept coming off down here. We flipped it around. God, I keep making silly mistakes. I'm saying like, let's go -5 plus 10, and then I'm entering like them the opposite way around. But at least I'm doing the levels now. We are completing them. This one's complete. So, doing pretty well. Doing pretty well. Didn't that count? Didn't that count? I just did it. Well, let's do it again, I guess. Plus 25 plus 5. Plus 5. Initial velocity, negative and... No, sorry. Negative and positive. From 5. And then from 5... It doesn't really matter, actually, because it's the same. So if we do that from, you know, to 4, and this is from 4 to 8, as long as it's -4, -4, that's totally fine. Here we're going to teleport to positive 10. And that's pretty much it. I think we need to let this run through. Oh, once again. Oh, wait a second. Once again, it teleported us too early. Where's the teleportation? There it is. There it is. There we go. Come on, run it again, please. There we go. It's the guy in the air. That's so awesome. Why is it not letting me, like, complete level? Ah! It's because I'm crashing into the wall before the end of the 8 seconds. We need to decelerate. No, we don't need to decelerate. We need to decelerate. Oh my god. We've got 1, 2, 3, 4, 5, 6, 7, 8. But our acceleration is too much. So we still want to do this for 5 seconds. And then we'll try to decelerate. Oh, no, it's the opposite. Okay. So this is smashing us into that wall then. Is it? 6, 7, 8, 9, 10. Yeah, it is. It's getting us there too fast. It's getting us there a little bit too fast. So the displacement's good on this curve, but then when we teleport, we need to be doing something a little bit different. So, what is this curve like? We are going kind of down at this angle, so we're still trying to displace negatively into the y from 0 to -10 to -20 to -30. That to me seems like it should be 0 then. Isn't that what 0 told us? Yeah, that's what I expected from 0 as well. Okay. Huh. You can get to here. We could skip the 5th second. Can we actually do that? 5. And then from 6 to 8. That seems very strange. I know it sounds so weird. I just want to see what will happen now. Like we hit this and then we start these accelerating again. That's funny. But we do need to be down there in that kind of speed. So, what are we? We're doing the -4 for this displacement. -4, 8, 12, 12, 8, 0, 12, right? Then when we're through here, this displacement is 10, 10, 10 on the Y. So if we do it instead on the X, it shoots down here. If we're trying to displace to positive X, right? To positive X, because no, wait. We're moving across here and here. No, we're moving here and here. So we're going across here and then we're displacing down here. Then when we're here, we're still moving at this angle. We're still moving at negative X, positive Y. But now this is like pulling us right down. Huh. So from, okay, so this should be the displacement. What should it be? 25 to what we're looking at? 8, 12, 12. Yeah, there we go. So it's the 5 to the 13. We got the 8, we got the 12, we got the 12, the 8 again. And then we go, it's back to 0. Yeah. And then 12. So this to this is not 12 though. So why do we hit that first one? If we do it the same. If we keep this at -4 also. Doesn't work. Because this needs to go 10. So we got X 9. And we got 16. What's 9, 16? This is 2. If we go 2 on X instead. So we're going for a completely different thing there when we come down here. And we're displacing off to the side. But we still crash just a little bit before. We're still crashing a little bit before. Huh. Just a little bit before. Why are we crashing? 1, 2, 3, 4, 5. We teleport there and we go 6, 7, 8. But it's just a little bit too fast. I wonder if we can teleport a little bit further back. What would be the one before it though? Because this is 9, 16, 21, right? This is the difference between... We got the 10 and we got the 1, that's the 9. And then the 10 and the -6, we got the 16. And this should be 21, not -11, yeah. But what would be before that, right? Can we work from that instead? Should we be trying to do that? Because we really don't have much time left. Look at that, we've got a little bit of time left. Let me just see if we can teleport. No. No, that's the initial position. Damn it, that's 25, 5, yeah. And then when we teleport, why wouldn't we just go an extra 5 here? Will it actually pull us... This is weird, because now we'll actually... No, because we'll be here. We want to be, like, here. Just up 1 here, see if that curve still works. Yeah. It does kind of get there. It does kind of get there. What if we... So this is, you know... I wish we could figure out the table before, but we don't know it. We don't know it. You know, this difference is 7. They're all different. They're all different. And I was saying this -24 should be -27, but obviously it shouldn't, because this is where they arc back around when they come back on themselves. Like this 0 and then coming back through it. Okay. How do we survive for just an extra second? I don't know. I don't know. We can't change that. It just... The acceleration will kill us. We just won't get there anyway. We'll get there even faster apparently. From 7, yeah. Huh. What if we teleport here then? And then we shoot down here for a second, don't we? Wait. What is that, at 5 seconds? Yeah. 0 to 6. That's why. That's screwing us up, because at 5 seconds we change. That's screwing us up. At 5 seconds we change. Let me just change this back to 0, and we'll see. We're not getting these timings set up. It's 1, 2, 3, 4, 5. And then we start supposed to be displacing. Yeah. It screwed us up. It screwed us up because it's still accelerating with the other one for an extra second. I was so just confused about what's going on when it was we kind of were figuring it out. What was it, 9? Oh, it's positive 2. It's because they had an extra full second of acceleration on the Y and it was killing us. That was so silly. We had no issue at all, and I was looking for the. We were like trying to debug code then. That were really funny. And that was just nonsense. We totally had that. Right, let's read through some of these guides. I think we're starting to get the hang of it. We've almost got 200 batteries, but damn, if this game, it's getting harder, and I like that. That's so much better. Edmund Halley, in 1684, while studying the orbit of the planets, he went to see Newton to ask him if he knew the form an orbit takes if the force of attraction of the sun is proportional to 1 over r squared. And it implied an ellipse, and I can prove it. This event triggered the writing of Principia, the treatise on mechanical physics which would revolutionize the world as they knew it. He discovers, using Kepler's third law and Huygens' law of centrifugal force, that the sun's force of attraction is 1 over r squared. He studied the trajectory of the comet that now bears his name, Halley's Comet. With Newton's law, he successfully predicted its return in 1758. See that once in your lifetime, apparently. Once or twice in a lifetime. Every 60 to 70 years, that's crazy. Here is Pierre Varignon. He considerably simplified Newton's work by introducing the concept of instantaneous velocity and accelerating force. His efforts gave birth to mathematical physics. He found that when an object is in equilibrium, it is because the sum of the forces acting on the object is 0. This is the guy. This is the one that's getting us into all this physics trouble that we're playing now. Willem Jacob Gravesand. He developed experiments which aided in the validation of several laws of mechanical physics. As such, he helped to propagate Newton's ideas. He proved that the depth of a bullet falling into clay is proportional to the kinetic energy. Here is Pierre-Louis Moreau de Maupertuis. He discovered the principle of least action, a fundamental principle in physics. We actually read that from somebody else before, that they kind of had the idea. And I suppose then he went on and perfected it. During an expedition to the poles, he experimentally confirmed the bursting of the Earth at the poles predicted by Newton, which makes his laws even more relevant. He was a musketeer. Okay, very cool. Very cool. Let's go. Last one of this area, and then we're on the stars. The stars, baby. Do we have a teleport here? We don't have a teleport. What we actually need to do is move down here and then curve back. Okay. So this is 0.25. Okay, so we can start wherever we want, but let's start at the bottom and worm our way up. We will start at 0, -25. Our initial velocity will be positive y and positive x. And we will accelerate. We want a displacement of his x is from 0. We want it's 12. And then 0, then -12. Can we find that's 12? I know there's 12 0 over here, negative. But that's not gonna work. Oh, we have 2. We have 2 accelerations. So we want 12 and 0, and that's we have 10 seconds, so we actually need to be here in 5 seconds. So this is all wrong, because we have 1, 2, 3, 4, 5. So we actually want this to be 5, which means we probably want this to be 5. So we need to, don't we need to double this now? In 5 seconds here, 0. That's perfect. Is that what we're going for? In 5 seconds to be at 0. in 3 seconds. So 1, 2, 3 at the midway to be at want to be at 12. So -4 on X is what I'm thinking. And then when we get 5 seconds in, and then 5 to 10, we'll go +4. Let's see. Whoa! Straight into that bomb, buddy. Straight into that bomb. That's because the X still needs to be 10. Because that's how the displacement works. We need it to be a positive or a negative of 10. I don't know why I did it the other way. This was a very simple one. We've done it. We're getting to grips with it. The mechanics of it. I like that a lot. I like to feel like I'm getting there. This game has been incredible fun. I'm like addicted to this. I've been telling so many people about it. All I've wanted to do, like all day, is come back and play more of this game. It's exhausting. It can be exhausting, but all I wanted to do was come back and play more. Here is Alex Cloud Claraud. By using Newton's law, he mapped the trajectory of Halley's Comet and predicted a 200-day shift from Halley's prediction due to a disturbance from Jupiter and Saturn. This proved to be a major victory for Newton's law. He was a part of Maupertuis's expedition to verify the flattening of the Earth and Newton's theory. He developed a detailed theory of the movement of the moon. And just 10 years old, he was able to grasp books meant for university students. Jesus. University students aren't very smart, though. I'm a university student, so... But then again, I studied programming. Which is very basic mathematics, to be honest, and more problem solving than anything else. You know, than actual, you know, going into anything deeper. Look at this guy, though. He's got the same nose as me. Look at that. Look at that. The big bridge of the nose, the big giant nose on him. Let's have a look. Of the Chang'e 3 on December 14th, 2013. Chang'e 3. I thought it was Chang'e. Yeah, it's spelled wrong here, I think. Became the first lunar module to land on the moon since Luna 24 in 1976. It was the third Chang'e mission developed by the Chinese, Chinese National Space Administration. Chang'e 3 also had a small autonomous vehicle named U2, very cute, which could move around and scan the ground after traveling a distance of over 100 miles, I suppose that's supposed to be, in 1 month. U2 stopped working due to undetermined causes. Oh, poor U2. Looks like Johnny 5 there. We are going to do this one and this one, and then we're going to attempt these, right? That's the goal of this video. Let's see if we can get these two knocked out quickly. Oh, you know what? I didn't even read what these levels are. What is this star? What the heck is this star? Because of this 1D acceleration in 1 dimension, the concept of acceleration and velocity in 2 dimensions. The 9 craters allow you to add along an axis a non-zero initial velocity to acceleration. And this one is offering an additional challenge compared to the concept of acceleration. Okay, so it's just more of the same, but challenging. I like it. I like it. Every crater should have that. That's good. Let's go. So we are at 0, 0, and we can't change it. We have no initial velocity. And we need an acceleration. We need to be here, then here, then here. Okay, well, where is this? This is 1, 3, and this is 4, 12. Oh, wait, this is 3, 1, and 12, 4. So we need. Where are we going here? We don't need that. We need this, right? Okay, so we've got 3, 12, we've got 1, 4. So along one axis, we're going, you can see we're going 3, we're going 12, we're going 27, we're going 3, 12, 27. So along the x-axis, we are going +6. And then you can see we're going 1, we're going 4, we're going 9 on the y-axis. 1, 4, 9 on the y-axis, we're going 2. So this is what it's trying to trick us now. It's trying to, you know, we're using both. And now we're going negatively because I'm an idiot. Still got me. Oh wait, no, positive on the Y. I'm still an idiot. It's funny, I like solved it and I was like, yeah, you can't get me, game. And then instantly just wrong direction. Wrong direction because we're going negatively. That's brilliant. Done. Solved. Leonhard Euler. Here is Leonhard Euler. Leonhard Euler. His work on the perturbations of the orbits of Jupiter and Saturn and on the precession of the equinoxes solidified the pertinence of Newton's law. He gave a precise mathematical proof for the principle of least action. He founded the mechanics of the solid. He set out the general principle of fluid mechanics. In mathematics, he is considered the founder of analysis. He is also regarded as one of the greatest mathematicians of all time. Euler. The E. Euler's E. Which according to Dr. James Graham on Numberphile doesn't stand for Euler, but I don't know. Seems like it would do. Seems like it would do. We are going to start down here. Minus 35. 35 minus 35. Minus 35. And we are going to go... So... Oh. Is that what we can do? Well, we have an acceleration of 10 and 10. And this is going to be a parabola, right? Well, yeah. Parabola. Okay. So if I'm going positive y, and if we're going negative x, actually. I'm going positive y, and you go negative x, and this is going to pull us back from 0 to 3. This is going to be really fast. 10 and 10. All right. Pretty simple stuff, that one. We'd already figured that one out. Let's go. Woo! Jean Leronde de Lambert. In his treatise on dynamics, specifically on the forces and the movements which they produce, he founded rational mechanics. This branch of physics combines advanced mathematics and Newton's laws. He gave an approximate solution to the three-body problem. The problem predicts the movement of three objects, in this case the Earth, the Moon, and the Sun. Solving this problem is very complex. He made several important contributions to the field of fluid mechanics. He found the equation for a propagating wave. To discover this equation, he was the first to use the concept of partial derivatives. The type of derivative, which comes from infinitesimal calculus, is still used in physics today. Is partial derivatives. Partial derivatives. Is that the one you use? Is that what you use the gamma icon for? Partial derivative. No, the gamma icon's for using partial numbers with... No, it's not. It's not. No. The gamma is for when you're using like 1.5 oh my god, what's it called? The exclamation point. So you multiply it by everything. Okay. Yeah. Partial derivatives. This type of derivative which comes from... Oh my god, what's it called in maths? The exclamation point. And you're multiplying from everything kind of before it. Okay, anyway, it doesn't matter. He found the equation for a propagating wave. Well done. Well done, my boy. We're going to try some incredibly difficult challenges now, and we're probably going to fail. So, Mr. Eric Laflamme, if you're still watching me and laughing at me, because listen to what he said, actually. I noticed this the other day. I'm opening Discord as we speak. It's taking a while. I don't know what's wrong with Discord. Discordo! We go to Dom. We're going to search for Space Tow Truck. And then he said, I'm the game dev of Space Tow Truck. I already read this out here a little bit. But when I said in the demo, this is a little bit easy though. What I want is more, to be more complex. What I meant was this. I wanted it to be more like this, the level 5, 6, and 7. He told me, I can assure you that the puzzles of my game become a lot more challenging than chapters 1 and 2. If you want a real challenge, I suggest you do chapters 5, 6, and 7. That's what he said. But then I think, very sarcastically, I'm pretty sure, he's like, he said, I believe we lack games to feel, understand, and democratize pre-university physics, so I didn't want to lose players in the first levels. Even for someone who never did physics in his life, the downside of this is that brilliant players like you could get bored talking to me. And I think he's just just attacking me, right? Like making a joke at my expense, like, oh, you're too good for my puzzles, my early puzzles. But if you want a challenge, try puzzles 5, 6, 7. And now here we are getting like beat down by puzzles on World 5, right? That's I noticed that the other day and I was like, ooh, Mr. LaFlamme, I'm gonna defeat your game if it's the last thing I do. So let's move on to the next one, see what he's got for us here. This is a big jump in difficulty. Uah, uah. Yeah. So we have 4 acceleration changes. 4. I'm assuming we can't start here. So we're going to start here, which is minus 25, minus 20. Plus 20. I'm so bad with my axes for some reason. I always read them YX, and I don't know what it is, and I keep jumping around. We're going to go here. We are going to go positively in the X direction. We are going to go positively in the Y direction. We have 20 seconds. We are going to change every 5 seconds, I would say. Yeah? Does that seem reasonable? So we're going to go 1, 2, 3, 4, 5. No, I think we want to go down here and then change acceleration. Here, change acceleration. And then, like, here, change acceleration, right? Let's try. Let's just give it a shot. We're going to go 1, 2, 3, 4, 5, 6, 7 seconds. Oh, we can only go 6. So we can't. We go 1, 2, 3, 4, 5, 6. This is a parabola, so we're going to change here. When we've come full around on ourselves. So 1, 2, 3, 4, 5. Perfect. From 5 seconds. And we're going to displace. We've got 20 to 8. 8 to 32. That's 12. That's 12. That's going to be 8 again. We know exactly which one this is. It's the 8, 12, 12, 8. And that is going to be negative 4 then on... And where are we... What are we pulling away from? This is on the Y. So negative 4 on the Y. Why don't we test before we do anything else? We should be getting to here in 5 seconds. 4, 5. Perfect. And then... From there, we're going to re-accelerate. We're going to re-accelerate. That's a word I've just created. You can have that, Mr. Eric LaFlamme. It's yours. You can teach that in your class. We're going to re-accelerate back on this parabola. So from here to here. And this one is going to displace us on the X, I assume. We're going to displace X. We are 25. 32, we got 7. And then an extra... Oh, no, it's the same. We've got... Here, wait, 5? We got 7. 12. Wait. 25, 32. 7. 12. 7. That's weird, because it's... I know it's this one. So we're doing... This is all wrong. This is all wrong. Do we still want to be going on the Y? That's 20, that's 10, that's 0. No, we don't. We want to be going into the X. But this is 25 to 32. That's a difference of 7. Then we're going from to 37, difference of 12, then a difference of 12, then a difference of 7, and then a difference of 0. That's weird. Because this is not how that works. Can we just input this same thing again? And we are going to be going minus X, so are we doing this? Minus 4? Let me see. This is super weird. Ah, yeah. Are they incorrect then? Are they incorrect? Are they incorrect? Maybe they are. Maybe they're a little bit incorrect. The 7 should be 8. This should be 8 and this should be 8. I don't know. Because it goes 8, 12, 12, 8. Not 7, 12, 12, 7. Okay. Doesn't matter. We made it to here. And then we change our acceleration once again. We're going to be going on this parabola now. We know how this works. So now once again, we're going to be going parabola on the y, and we're going to be going positively into the y direction. So this is 30, 38, 12, 12, 8. Yeah, so I think these are incorrect then, right? These should be 8 and 8, not 7 and 7 difference. Am I doing that correctly? Yeah, that should be they should be 33, right? I don't know. I don't know why, because these ones, the difference between we've got here 30 and we've got 38, and here we've got 25 and 32. Strange. Anyway, we'll just go ahead and do it. So once again, we're going to be going, this time we're going positively into the 4. And then once we're here, what is the parabola here now? Now we're going the opposite way. So we want to displace into the y negatively. And we want to be displacing into the y negatively. So if minus 30, 21, that's 9. Then we got 16. So where's 9, 16? That's 2. And we are going to be going negative 2. Let's try this out. 20 seconds. And we go the second parabola. Make it around. The third parabola. The fourth parabola. Mr. Eric LaFlamme. That's your challenge 9? That's your challenge 9? I say come at me, bro. I say come at me, bro. I mean, that was all, I know it was only the first challenge. I know there's 3 more to do, but I mean, pretty solid. Pretty solid work. Joseph Black. We have earned your information. We are going to enjoy reading it. Here is Joseph Black. He discovered latent heat, which is the heat used to change the state of a material, solid, liquid, or gas. This principle states that if a material has begun changing state but not yet completely changed, the temperature remains constant. Afterwards, the temperature can continue to rise. Strange. He discovered the specific heat of materials, which is the capacity for a material to accumulate energy in thermal form. He discovered carbon dioxide, CO2, and that is produced by animal respiration. That's a nice way to put it. Yep. Just animal respiration. That's all it is. How long do we have? 57. Let's jump into it. Just see if we can steal another one quickly, because this looks like one parabola also, but it's not, is it? Because these aren't equal here. This is a lopsided parabola. This is a lopsided parabola. This doesn't work unless this is a lopsided parabola. This is too weird. So our starting position is very obviously going to be positive 10 minus 15. Our initial velocity needs to be positive y and negative x. So we're going over this way. Then we are going to displace into the positive y to here, onto here. We are going to displace for 1, 2, 3, 4, 5 seconds. And then we're going to do this from 6 to 8. We are going to go from 15 to 10. That's 5. Then it's 10. Oh no, wait. We're going this way. So we want to displace positively into the x. So 10, 1, that's 9, and then we know this one. 9, 16, that's 2. So we're gonna go positive 2. And then after so many seconds we should hit here. And then from here, we are going to go. We can go this way. So where are we going? We're going to displace. We're still going to displace positively into the x, aren't we? But this time it's x 15. We've got now it's 3. And then 12. No? Is that not correct? 15 to 12, that's 3. 15 to 3. 12, 3, 12, 3, 12, 3, 12. No, we're doing that incorrect then. In that case, we're going to go into the y. negatively, because, oh, this parabola is going to pull us back down after a while. So we want to be going negatively into the y. So y is 10, and then it's 15, and then it's 20. It's 25? No. No. No, 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 no. It's not going to go 5, then 10, then 35. That doesn't work. 5, 10, 35. No, 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 no. No. 5, 0, 15. No. No, no, no. What am I doing wrong here? We get here. And we have 3 seconds. Oh, we need to do both, do we? Can we do that? So that's 5. That's 10. 25 from 10. Oh, wait. That is 15. Yeah. That's minus 5. Huh. 5, 10, 15 though, not 5, 0, 15. Okay. And then, so that's 10 to 15, yeah, 5. 10 to 20, that's 10. 10 to 25, that's 15. 5, 10, 15. We can't do that from here. That's going to just happen. If we do 15 to minus 15 to minus 12, the 3. And then the 12. And then the 3, 12, and then what is this? It's minus 15, positive 12. Okay, so we got 27. About 3, 12, 27. Wait. Ah. Yeah, 3, 12, 27. Here we go. That's what we're trying to do now. So 6. But doesn't that mean... Oh, wait. Whoa. Am I... Wait. Whoa. We're going negatively into the... X. There we go. Oh! Did that start too late, did it? Wait. Where did that start? It needed to start there. 5 seconds. Did it not? Oh, it started at 6 seconds. To 5 seconds then. And then this at 5 to 8. Oh, and it's once again, I'm doing that stupid overwriting thing. Okay. I changed the Y because we don't need to move as fast in the Y, but you still need the minus 10 to hit the to calculations on the graphs. That's your second level 9 level gone, Mr. LaFlam. I just poked myself in the eye. Boom. Done. Hendry. Henry Cavendish, through famous experimentation using a torsion balance, 2 identical 158 kilogram masses, and a small 730 gram ball, he determined the value of the universal gravitational constant G. He was a peerless experimenter. He demonstrated the 1 over R2 law for the electric field and gave a first experimental verification of Ohm's law 50 years before it was formulated. Jeez. He discovered hydrogen. He possessed a prodigious fortune but lived very modestly. He was a very eccentric and incredibly misogynistic character who had a very quiet social life. That's probably for the best. He sounds kind of like a jackass, but incredibly clever. So, I mean, thank you for discovering hydrogen, sir. Great. That's 2 out of 4 done. Let's look on to these next ones, because I don't think there are any more level 9 challenges in this game. Oh, there are 2 more here on the last area. That's going to be hard. But there are only 6 in this whole game. We've already beat 2 of them. And I think pretty well. Like, pretty fairly, like, just dusted them. You know what I mean? Like, figured you out. We know how to solve these now. Get out of here. Acceleration and velocity in 2 dimensions. Dude, we can do acceleration and velocity in three dimensions. Definitely. Please don't add that to the game. That will kill me. This is incredible. This is so fun. And I know I needed to go back. The beginning of this episode was a little weird because I had to go back and kind of explain what I'd done to understand what I was missing. And it was that we were needed to the velocity on both axes at the same time. Very silly of me. But for the parabolic movement, but so fun. So once we figured it out, we just crushed these levels. These ones were just gone, even these more challenging ones. I'm very excited to start a new video and jump straight into these other 2 level 9 ones. I want to burn them before we move on. I'm very, very excited for part 6 though. Gravity. And part 7, the black holes, baby. I'm coming for you. See you next time. That space tow truck. If you like the look of this, go play it. Go play it right now. It's so cool. So cool. It makes you feel really clever for figuring stuff out. And the thing is, even if you don't understand the underlying maths or physics behind it, there are only so many solutions. And I know you can't just like click about and get the right answer, but you can start, you know, with some trial and error, you can definitely get there. You know you need to be negatively here and positively here, and you can just kind of try, okay, -2, -4, you know, if you're not getting exactly what's going on, you can kind of work your way there and then work backwards from that. Like, okay, that was the answer. How would I have come to that, you know, otherwise? And I think that's a really good way to get through it as well. We haven't used any of the hints, but I'm sure they're also very useful. But thanks for watching. I'm loving this. I'll see you next time. Bye.